Hello dear programmer, I welcome you all in the lecture series of Fundamentals of Data Structure. In the last session we have seen that how to represent the algorithm in terms of the Sudoku. If we are having multiple algorithms or the two algorithms are with us, then we have checked how to check the efficiency of that algorithm. Also we discussed that algorithm's efficiency as the function of the number of elements to be processed. So we said that f of n is equal to efficiency. In today's session, we are going to see how to check performance analysis. If we are taking an algorithm, then the algorithm's complexity can be checked by two ways, space complexity and the time complexity. At the end of the session, I expect my student will be able to understand what is the performance analysis. They can be able to analyze and predict the performance of given algorithm in terms of asymptotic notations. These are the reference book we are going to refer for our session. So let me start with the performance analysis. As we discussed that the algorithm's efficiency can be, if it is a focus on the looping, then it can be logarithmic loop. If it is a linear loop, then we are saying f of n is equal to n. If it is a linear logarithmic, then it is n log n. If it is a dependent quadratic, then we have seen that n into n plus 1 by 2. And for the cubic loop, it is n cube. The performance analysis means if we are having an algorithm and we want to check or judge our algorithm. So there are many criterias like first criteria is does it do what we want it to do? Means are we getting our expected result? Does it work correctly according to the original specification of the task? What is the quality? Is there documentation that describe how to use it and how it works? Do we have documentation? Are the procedure created in such a way that they perform logical subfunctions? What about the modularity of that algorithm? Is the code readable? So based on such a criterion, we can check the performance of our algorithm. So the performance evaluation is generally of into two phases, a posterior estimation and a prior estimation. In the prior estimation, it is nothing but the performance analysis. And in posterior testing, we are checking the performance measurement. While we think about that the analysis of an algorithm means we are checking the efficiency of that algorithm, which is calculated by measuring the performance of algorithm. As I said, the performance can be decided into two factors, space complexity and the time complexity. The space complexity focuses on how much space is required by an algorithm to execute, and the time complexity indicates how much time does it take to run the algorithm. So if we say about the space complexity of an algorithm, it is nothing but the amount of memory need to run for the completion of that particular algorithm. So if we say that S of p is equal to C plus S of P of instance characteristics, where we are saying that the C is of the fixed size. For example, if we are taking an algorithm in which some variables are being defined and some instructions are there, that instructions and the variables are the simple, means it always required the fixed size. So that's why we are saying that such a fixed or the constant is shown by the small c. And S of P is nothing but the variable part which is depends upon our problem instance characteristics. Means our space is completely based on this variable part. If we think about the time complexity, it is nothing but the amount of computer time it required to run the program or to execute the program. So the time complexity of a algorithm is equal to compile time plus execution time. But if we take that the compile time, which is a constant for the some programs, because it might be happen that we are running our program for the different types of inputs, but we are not compiling it again and again. So that's why the run type of program is important and which is depends on our instance characteristic. Means we are saying that the while we are calculating the time complexity, we are considering its execution time, that is run time, as compile time is a constant for the same program. If we think about the space complexity in detail, the space complexity is nothing but the amount of memory is required for that algorithm. So again it is of two parts, fixed part and variable part. So in the fixed part, it is not depends upon what the number or what is the size of the program's input and output. These are the fixed requirement are nothing but our instruction space, the space for certain data or the variable which is completely independent on the size of problem. But if you are considering about the variable part, then it is the space needed by the variable whose size is depends on the size of our problem. Many times we people are getting the coordinates error. Do you know why it comes? Yes, due to the amount of memory required is the larger than that of amount of memory is available on the given system. In that such a case, we are finding out such error. If we are thinking about the time complexity, space complexity, it is on the fixed part, is independent of input and output, and the variable part, it consists of the space needed by the component variable whose size is based on our particular problem. Now it's time to start with our time complexity. So time complexity is nothing but the compile time plus execution time. Compile time is a fixed space component. It does not depend on the instance characteristics because we may run the program multiple times without recompiling it. So that's why our time complexity is equal to execution time. So what is execution time? So execution time, it is nothing but the count, the number of operations are performed to that particular program, which is machine independent estimation. Determining the time complexity of that given algorithm is not the easy task as it because it requires a detailed knowledge of the compiler's attributes. For example, we must know how the compiler translates our source program into the object code. I- Once we are getting that information, then we need to get the system clock to the time program. But obtaining such information, it is really worth the effort. So alternatively, we could count the number of operations the program performs. So this gives us the machine independent estimate. But we must know how to divide the program into such a distinct step. So for this reason, we people are calculating the programming step. A programming step is the syntactically or semantically meaningful program segment whose execution time is independent of instance characteristics. Means we are determining the number of steps that the program needed to solve that particular problem. So for this reason, we are taking a one variable. That variable we are calling as a global variable. Initially, that global variable is set to 0. Then we are incrementing this global variable at every step wherever actual execution has been done. Let me see this example. So can you judge for what the code we are using it? Yes, of course. This is nothing but that 2 matrix addition. And the result will be stored in third matrix, that is C. Now we can determine the number of steps that a program or the function need to solve a particular problem instance by creating the global variable, that is count, which has initially value 0. Then inserting the statement that increments count by the number of program steps is required by each executable statement. So whatever the step count sum is nothing but our program's total count. So we are saying that the first outer for loop will be executed based on that what is the value of rows, and inner for loop will be based on that outer for loop. Means while our row is 1 or I is 1, that time j becomes that 0, 1, 2 and so on. Means we can say that our outer for loop is going to control our inner for loop. So that's why we are saying that we are increasing the count by 1 for here I for loop. After that, here is again computation has been done. That's why we are saying this count will be increased for our jth for loop and then for our assessment statement. Now, if we have seen that, assume that our row size is 4. So I is 0. 0 is less than 4? Yes. I becomes 1, 1 is less than 4, yes. I becomes 2, 2 is less than 4, yes. Then 3 is less than 4, yes. Now 4 is less than 4. For that false condition, we didn't enter into this for loop. So for this reason, we have to keep another increment step which indicates that we are checking for our false condition. So if we add this sum of this count, which gives us how much time we are expect this program has to run. So it is completely based on what is the value of rows variable and the columns variable. Take this another example. So if you have observed in this program where we have been initialized the count statement only where the executable statements are there. So that's why automatically we are eliminating the function header and the second variable declaration from our consideration. Then initially we have set the count is equal to 0. Then we are taking this count for this initialization, or we can say the assignment statement. We are not considering such a declaration statement. Then this count will be increased for our for loop, and this count statement will be used for our assignment statement. This is the count for our last execution of our for loop, and as the function is returning something, that's why we are taking this count. So if you have observed, the count initial value is 0 and its final value will be 2n plus 3, which is based on what is the size of our n. So that each evocation of sum executes the total is 2n plus 3 steps. Means for this program, we are requiring 2n plus 3 step count. This now in this method that putting the count everywhere that execution is being happened, it is a bit difficult. So we have the another method is second method where we are using frequency count. It is a one tabular method. It uses a one table in that we determine the step count for each statement. That means steps per execution. Then we are finding the number of times that each statement is executed. That is called frequency. If the statement is non-executable, then its frequency is 0. Then we are going to multiply these steps per execution with frequency and we get total steps for each statement. And at the end, we need to do the summation of all these total steps. We'll get the step count for that entire function. Let me have at shown here. Now, if you have observed, this is a declaration of our header of our function. So that's why it is not having the steps per execution is 0. Means for this given statement, we need to create a table. That table is consist of steps per execution for each statement. And then we need to figure out what is the frequency column. And at the end, we are maintaining the total steps. So for that declaration also we are not using. That's why we say that steps per execution is 0. Now here for this one, it will be executed for temp sum is equal to 0. Here assignment statement means we are executing this step for one time. Again this will be continued for the steps for execution will be 1. Means here these statements are executed 1. Then later on we need to count the frequency. So the frequency for this for loop is n plus 1. Means for our I is equal to 0 to a value of I is become n. So n is less than n. It is the false means we are having that n is for our false condition. Then as this statement will be executed based on the value of I. So this statement will be executed n times. That's why the frequency is n. As it is returning some value, that's why it takes only one frequency. Means the frequency indicates that the number of times that each statement is executed. Then later we need to their addition. So if we have funded out, then we are getting the actual or the total steps for this given statement is nothing but that 2n plus 3. Take this another example. Here we are having the header. So header is not executed. So it will be not, that's why it is 0. Then for declaration statement it is also 0. And if you have observed that this statement will be executed means one steps per execution will be executed, but its frequency is again rows plus 1. If you have identified that it based on the value of rows, that's why the frequency of this statement is nothing but that rows into rows plus 1. And this statement is based on the values of rows and the columns. That's why this statement will be executed based on the rows multiplied by columns. If you take that example, our matrix is of 2 by 2. Means we are saying that this particular statement will going to be filled. The values are 0, 0, 0, 1 and 0, 1, 0, 1, 1. Means this statement will be executed completely 4 times. Then later on, we need to add these total steps. So these total steps gives us that the total frequency count or the total step count for this addition of two matrix is 2 rows multiplied by columns plus 2 rows plus 1. So we can say that the time complexity of a program is given by the number of steps taken by that program to compute the function for what the purpose it was. The number of steps itself is a function of instance characteristics. Let me have this another example. Now here it shows that how much size it is going to be executed. So we need to calculate for each and every statements, and at the end we need to do their addition. So we can say that this complete for loop means that the for I is controlling j and I j both are controlling to our k. So in this case we have to compute, and at the end we are getting that the frequency count is n cube plus 6n square plus 11n and 3 divided by 3. So like this fashion we can compute the time complexity. So dear student, I expect you kindly pause the video and try to calculate what is the frequency count for this given example. I expect my student have created the table. I will show you how it has been. So we are saying that this is the assignment statement. That's why for this line number 1, then the frequency is 1. If you have observed, then this particular frequency, particular statement will be executed into 2 into n plus 1, 2n plus 2. And here we are saying that the partial sum is equal to I multiplied by I multiplied by I. Means here we are saying partial sum is equal to partial sum plus I multiplied by I multiplied by I. So we are saying that for this line number 1 and the 4, for this both, it is count is only 1. But line number 3 is executed complete n times. Means here are the 4 units. That's why we are saying it is 4n. And if we think about for this line number 2, here is 1 for initialization and n plus 1 for all the test comparison I less than n, and n for our increments. So total 2n plus 2. So like this fashion we can compute that its total cost is 6n plus 4. We'll see that what is this O. This is called as big O in next lecture. So dear student, we have seen that the performance measurement means need to obtain the space and time complexity for the given algorithm. The purpose of the posterior testing is to estimate the runtime of the given problem and to compare the two algorithms for their runtime. It might be possible that the time and the space trade-off means if for the given algorithm is the computation time is more, then the space can be less, or for some algorithm if the space is more, then computation can be less. So I hope you understand that how we have to compute time complexity for our given algorithm. Thank you. Happy learning.